Yes, they're ticking time bombs, and I'm about to show you exactly how to identify them in your gun right now. Your $1,500 defensive handgun has a fatal flaw hidden inside the slide. The extractor, the part that rips spent brass from the chamber every time you fire, is not machined steel. It's metal dust baked in an oven. MIM, metal injection molding, 1997, a Colt. 1911 extractor was forged tool steel, 200,000 rounds still running. 2025, that same part is powdered metal mixed with plastic binder, squeezed into a mold like a toy soldier and sintered in an oven. It cost the manufacturer 40 cents. You paid $1,500. Here's what they don't tell you. MIM parts are porous, microscopic voids trapped between particles. Under stress, they don't bend, they shatter. No warning, no gradual wear. One moment you rack the slide and everything feels normal. The next moment, you press the trigger and nothing happens because the extractor snapped off and jammed your gun. If this happens at the range, it's annoying. If this happens when someone kicks in your door at 3 a.m., you just died holding an expensive metal brick. The manufacturers know. Internal failure reports have documented MIM failures since the early 2000s, but the retail price didn't go down when they switched. It went up. A Smith & Wesson revolver in 1985 with forged internals cost $400. Today, with MIM parts, $700. They saved $14.60 per gun. You paid full price for a critical failure point engineered into your defensive weapon from day one. Here's how to identify MIM parts in your gun, why they fail, and which manufacturers are still lying to your face. Metal injection molding, MIM. If you have purchased any modern firearm in the last 15 years, you own parts made with this process, and the chances are extremely high that nobody told you. Walk into any gun store today and pick up a brand new polymer-framed 9mm marketed for law enforcement and concealed carry. The exterior looks bomb-proof. Aggressive slide. Serrations, night sights, every tactical feature you could want. The marketing materials call it duty grade. The price tag says premium, but crack open that slide and look at the extractor, the striker sleeve, the sear, and the firing pin safety plunger. What you are holding in your hand is not forged steel. It is not milled from billet. It is powdered metal mixed with a polymer binder, squeezed into a plastic injection mold like a toy action figure, and baked in an industrial oven until the binder burns off and the metal particles fuse together. The manufacturer saved $14 per gun. You paid full price for a critical failure point that was engineered into the weapon from day one. Here is what they are not telling you about the MIM process. Real forging involves taking a solid block of steel, heating it to the point where the molecular structure becomes plastic, and then hammering it under thousands of tons of pressure until the grain structure aligns in the direction of stress. That part becomes dense, uniform, and predictable. Machining takes a forged or cast blank and removes material with cutting tools until you have the exact dimensions required, and every surface is smooth and controlled. Both processes produce parts with consistent material properties. You can test them, you can predict their lifespan, and when they finally do wear out after decades of hard use, they wear gradually. You get warning signs. MIM does not work that way. MIM starts with metal powder, usually a pre-alloyed stainless or carbon steel that has been ground down to the consistency of flour. This powder is mixed with a thermoplastic binder, the same type of polymer used in disposable plastic forks. The mixture is injected into a mold under pressure, ejected, and then placed in a sintering oven where the binder is burned away and the metal particles are fused together at a temperature just below the melting point of the steel. The problem is that this process leaves voids. Microscopic air pockets trapped between the particles, uneven density throughout the part, inclusions where the binder did not completely burn away. The finished MIM part looks identical to a machined part on the outside, but internally it is porous, inconsistent, and fundamentally weaker. Now, let's talk about what happens when you put that part inside a firearm. Every time you pull the trigger, you are detonating a small controlled explosion 6 inches from your face. The slide is traveling rearward at violent speed. The extractor is hooking the rim of a spent casing and ripping it out of the chamber against spring tension and friction. The sear is holding back the striker under 15 pounds of compression until the exact microsecond it needs to release. A machined steel part in this environment will flex under stress. The molecular structure has enough uniformity and ductility to absorb shock, distribute force, and return to its original shape. A MIM part does not flex, it shatters. The voids inside the metal act as stress concentrators. Imagine a frozen candy bar. Tap it lightly and it cracks clean in half. That is what happens to a MIM extractor after 5,000 rounds, or 15,000, or sometimes in the first 100 if you got a bad batch. There is no bending, no deformation, no warning. One moment you rack the slide and everything feels normal. The next moment, you press the trigger and nothing happens because the extractor snapped off and your brass is jammed halfway in the ejection port. If this happens at the range, it is an annoying malfunction. If this happens when someone kicks in your door at 3 in the morning, you just died holding an expensive metal brick. The manufacturers know this. Internal failure reports from major firearms companies have documented MIM extractor failures since the early 2000s. Gunsmiths who work on police trade-ins see broken MIM parts constantly. But here's the criminal part. The retail price did not go down when they switched to MIM. A Smith & Wesson revolver in 1985 with a forged hammer and trigger cost $400. A Smith & Wesson revolver today with MIM internals costs $700. Sig Sauer replaced their milled German steel with MIM parts made in New Hampshire and raised the price. Colt switched to MIM in their 1911 line and kept charging custom shop rates. The customer is paying more money for an objectively inferior product, and the only people who benefit are the shareholders and the private equity firms that bought these legacy brands and gutted them for profit margins. Let's put a number on it. A properly machined extractor made from tool steel on a CNC mill costs the manufacturer approximately $15 when you factor in machine time, tooling wear, and skilled labor. A MIM extractor costs about 40 cents. The company pockets $14.60 per gun. Multiply that across every internal part they switch to MIM. Extractor, firing pin, sear, ejector, slide stop, magazine catch. You are looking at $70 to $90 in cost savings per firearm that the manufacturer kept while charging you the same price or higher. Now multiply that by a production run of 50,000 guns per year. That is $4.5 million in pure profit extracted by replacing real steel with sintered powder. And when your gun fails, they will blame your ammunition or your grip or your maintenance. They will tell you that MIM parts are perfectly adequate for the firearm's intended use. What they will not tell you is that the intended use in their corporate risk assessment is 500 rounds per year by a casual shooter who will never push the gun hard enough to expose the flaw before they sell it used, and it becomes someone else's problem. Here is how you protect yourself. First, if you own a modern firearm, you need to inspect the internals immediately. Look for a grainy, matte texture on parts, like the extractor and sear. Machined steel is smooth with visible tool marks. MIM has a surface that looks almost like cast iron, rough and porous under magnification. If you see that texture on a critical part, that part is living on borrowed time. Second, buy older guns. The golden age of American firearms was the 1980s and 1990s. Pre-lock Smith & Wesson revolvers, West German Sig Sauer pistols, Series 70 Colt 1911s. These guns were built before the bean counters took over. Every critical component was forged or machined, hand-fitted by gunsmiths who understood that a firearm is not a disposable consumer product. You can find these guns used for the same price or less than a new polymer wonder gun, and they will outlast you, your children, and your grandchildren. Third, if you already own a modern gun and you want to keep it, gut the internals and replace them with aftermarket machined parts. Companies like Apex Tactical, Wilson Combat, and Cylinder, and Slide make drop-in replacements for almost every popular platform. Yes, it costs another $200. But you are buying an actual tool steel part made by people who still care about durability instead of quarterly earnings reports. Fourth, support the manufacturers who refuse to go down this path. LMT, Bravo Company, and Daniel Defense still machine their critical components. Dan Wesson still hand-fits their 1911s the old way. These companies cost more up front because they did not cut corners. Buy from them. Reward the companies that treat you like an adult instead of a beta tester. The bottom line is this. The firearms industry spent a century building a reputation for reliability, durability, and American craftsmanship. Then, private equity discovered they could replace forged steel with baked metal powder, keep the price the same, and increase profit margins by double digits. They made that trade. They chose short-term profit over long-term integrity. And now you, the end user, are holding the bag with a gun that might work perfectly for 5 years or might catastrophically fail the first time you need it in a life or death situation. The companies will not warn you. The marketing will not mention it. But now you know. Check your guns. Replace the garbage and stop rewarding the corporations that are selling you out for 40 cents